Hello everyone. Today is Friday, May 22nd, 2026, and I am bringing you another training article from the archives. Oh, I almost forgot to mention, I am just hanging out here in the studio, talking to myself as usual, trying to make sense of all this crazy new technology. Stable audio free technical report. The quarrel is, cheats massive, places at 5.17,991 of them. It is long, but do not worry, we are going to break it down. Let us talk about the big problem this paper is trying to solve. Creating long audio like music or sound effects usually takes a massive amount of computing power, and if you only want a short sound, older diffusion models would still calculate the entire long sequence, wasting a ton of memory and basically nothing, just generating pure silence. It is like buying a whole pizza when you just want one pepperoni, and then you have to throw the rest in the ocean, which the fish probably hate because they prefer anchovies. Anyway, nobody ever gets my jokes, so let us move on. Stable Audio 3 introduces a family of fast latent diffusion models, which come in small, medium, and large sizes. They are built specifically for variable length audio generation and editing, meaning they can generate just the right amount of audio you need, from a quick 5-second sound effect to a full 6-minute track. This is a really huge deal in the AI world, because it completely avoids the cost of producing full-length generations for very short sounds. They achieve this magic using a novel semantic acoustic autoencoder, which basically takes the complex audio waveform and squishes it down into a highly compact latent space. Specifically, it downsamples the audio by 4,096 times, which is a massive compression ratio compared to older models. This extreme compression allows the main diffusion transformer to work way faster, preserving high-quality audio fidelity. Oh, I should also mention how it compares with other technology. In the past, aggressive models are popular because they naturally support variable lengths, spitting out audio tokens one by one until they are done. But ultra-aggressive models can be slow to sample from. On the other hand, latent diffusion models generate continuous representations all at once, which is great for quality, but traditionally they demanded a fixed sequence length. Stable Audio 3 bridges this gap beautifully, bringing the variable length superpower to latent diffusion. They use variable length attention mechanisms during training, masking out the padding so the model only learns from the actual audio signal. They do this clever thing called a parallel 10-step shift. The longer sequences are pushed toward higher noise levels during training, ensuring the model learns how to properly denoise complex, long-form audio structures. And the speed on this thing is absolutely bananas, because they use a 3-stage training pipeline, starting with flip matching pre-training, then a distillation warm-up, and finally adversarial post-training. The model learns to generate high-quality audio in just a few steps. By relying on a relativistic adversarial loss, the generator learns to output realistic audio directly, without suffering from the blurriness that usually comes from simple squared error distillation at inference time, at using a step ping-pong sampling method. If the model takes a step toward the clean audio, adds a little bit of noise back in, and refines it again, this self-correcting zigzag path allows them to generate several minutes of audio in less than 2 seconds on a high-end graphics card, and even a small model can run locally on a regular laptop in just a few seconds. Now let's talk about how this applies to everyday life, because that is where it gets really exciting for creators. I have got at least 3 specific application examples for you. Think about independent video game developers or filmmakers. They often need highly specific sound effects, like a heavy wooden door creaking or a futuristic laser blast. Instead of spending hours searching through expensive stock libraries, they can just type a prompt into Stable Audio 3 and generate the exact variable length sound effect they need on their own computer. This completely democratizes professional sound design, saving time and money while boosting creativity. Second, this technology is going to revolutionize music production workflows. Stable Audio 3 includes a powerful feature called painting, which lets you edit targeted segments of an existing audio track, Let us say a producer is working on a jazz track, and they love the overall vibe. Feel like the piano solo in the middle is just a bit lackluster. They can simply mask out that specific section, keep the rest of the track intact, and prompt the model to generate a wild new saxophone solo in that exact AD space. This transforms AI from a basic novelty into a precise, interactive tool for professional musicians, allowing for multi-segment edits without ruining the original composition. There is the amazing application of audio continuation, which is perfect for copyisters or content creators. Imagine you have a short, 10-second intro loop for your podcast, but suddenly you decide you need a full 2-minute background track to talk over. Instead of trying to manually loop it and making it sound repetitive, you can feed that short clip into the model, and use the continuation feature to seamlessly extend the music. The model will look at the existing audio context and generate a coherent, evolving continuation that sounds completely natural. This could also be used to finish a song idea if an artist is experiencing writer's block, giving them endless inspiration directly from their own starting point. To wrap things up, Stable Audio 3 is really pushing the boundaries of what open-weight models can do by releasing the weights for the small and medium models. We are landing anyone with a decent consumer-grade graphics card to experiment with state-of-the-art audio generation. The combination of the semantic acoustic attenuator, differential attention, and adversarial post-training makes this system incredibly robust. The fact that it can handle both music and sound effects in a single unified model, without needing that classifier-free guidance at inference time, shows how brilliantly optimized it is. It is a huge leap forward, and I cannot wait to see what the community builds with it. Alright, that is all I have for today. Thanks for listening to me ramble, and I will catch you in the next one.